So as I said before, I am going to try to marry the world of sides and angles together. They are one and the same if you understand this relationship. Marco, up here please. Here we go. First thing I need to introduce is a new variable. If we are working with functions, or if we're working with relations, we're working with equations, and we didn't know the value of a number, instead we gave it a different symbol. What was the typical symbol we give an unknown number? X. X. What's another letter that we commonly use? Y. Y. What is another letter you could use? A. Whatever, right? Any letter in the alphabet. When we talk about angles, I need to introduce some Greek letters. Anyone know what that one is? E. Sort of looks like it. It's a circle with a line through it. Yep.
Tan?
No, not exactly. It's a Greek letter. Anyone Greek here? No.
Toa?
Greek alphabet. Theta.
Oh,
It's weird. In the English alphabet, how do we spell the pronunciation th? TH. That's their th. Okay? So this is called theta. I'm totally butchering it here, but there are other letters you can use in the Greek alphabet. Anyone know any other Greek alphabet letters? Alpha. Alpha. What else? Beta. Beta. So like, alpha male, beta male, like stupid stuff. Okay, and what else?
Bravo.
I'm going to edit that out of the video. What else? Yes. Omega, right? So if we get a little biblical here, alpha and omega is beginning and the end because not exactly. Delta. Gamma. Kappa. I actually don't know how to do it. It's okay. There's other things like epsilon and all this other stuff. Delta, yeah, delta's in there.
Epsilon.
Yeah, no, that's where it all comes from. Okay, you're embarrassing me in front of the camera. Come here.
Charlie.
If we are talking about angles, you are to use any kind of Greek letter out there. So if this is theta and we want to talk about this angle, you can label that as alpha if you want to. Okay, you'll see that quite often. Here is the lesson start. If I have a relationship of this angle and the base to be 10, what do you notice happening to the angle if the base was to be bigger than 10? What happens to the angle? It looks like it's getting smaller. Okay, so if the base gets bigger, if the length gets bigger, the angle gets smaller. Okay, I'm not sure if I'm doing it justice, but let's pretend this is the same length. If the base became shorter than 10, what do you notice about the angle? It's getting larger. Okay, so if the base gets shorter, the angle gets larger. Oh, if the base gets larger, the angle gets shorter. I wonder, what if there is a relationship between the two? I wonder if there's a math behind that. And this is the birthplace of trigonometry. Are you ready? Ready for this? So now we're starting to investigate. We're starting to explore math a little bit. And this is where this weird thing, SOH CAH TOA, comes from. Entertain this for me, if you will. Here is your typical XY. I'm going to try to draw a circle, and the circle is where we're going to start. So here is my circle, and that is my center. I'm going to draw 3 lines for you. I'd like you to tell me something that you notice between those 3 lines, right? That's line A. That's line B. That's line C. What do you notice about those 3 lines? Yes? They're all the same length. How could you argue that?
It's circles, so all points are.
Right. What is the special word? Why did you know that it was the same length?
Radius.
You have the same. They have the same radius. Okay. So, yes, they all have the same radius. Okay. So we have established that this is R, that's an R, that they all have the same radius. I don't know what that is. Okay, but keep that in the back burner. Letter R. Now I'm going to try to take every single one of these lengths and create an imaginary triangle from our starting axis, which is an X. Okay? So here it is. Here we go. Okay, that's my A. That's my B. And if I'm doing a really bad job, I need you to imagine that these three solid lines are the same length. Okay, I'm just trying to reproduce that. Does everyone see where these lines are coming from? Yeah. Everyone's okay? Abby, you with me? Yeah? Super important, okay? All right. What do you notice as a relationship? As this angle becomes bigger, what do you notice happening to the height? Just as a pattern here, as a pattern. One person, two people. Daniel?
The length gets longer.
The height gets longer, or the height gets larger. And if I were to talk about it as x and y, what is the height represented as in terms of letters here? Between x and y, what is the height?
Y.
You see it, Dave? You see it? Okay. So we're talking about this height, that height, and that height. And it's getting bigger and bigger. Okay, so as we move through a circle, there's a relationship between angle and the height that is covered. In fact, now is the time I need to introduce to you a special word. Anyone here heard of the word sinusoidal? Yeah, of course, every day. I talk about it. I eat and sleep. Sinusoidal. The idea is this. Is there a reason why basketball is in the middle? This is a reason why. Sinusoidal is a word you might see in grade 11 in science and in math. It basically means this. A repetitive, predictable wave motion. So tell me some things that you see in nature that behave like this. Yeah?
Sound waves?
Sound wave? Yes and no. Waves, sound waves are a little bit special in waves in that instead of doing this, it does this. Right? That is sound waves, but yes, it's a kind of wave. What else might behave like this? Elephants?
Dolphin.
Yes, but dolphins aren't the most predictable. Oh, you guys are really creative. Come on. Okay, something not as creative as dolphins. Yep.
360 waves.
360 waves.
So
Like this.
He's talking about his head.
Oh, yo, I'm not cool enough for that, man. You have to like explain these. 360 waves. This is a failure of a video. Yes. Light, absolutely. Anyone who's done? You didn't put your hand up. Okay, everyone relax. Light waves, yes, they do behave. If you've gone through optics, I don't think you have yet. In grade 10 science, you go through optics and you will learn that light sends from the sun, comes to Earth, and it can travel without needing any kind of vehicle. You know that space is pretty much empty, right?
Yeah.
But light can still travel from the sun to the Earth. It doesn't need to ride anything. It still comes in the form of a wave. You'll see in English, science class. Here it is. Imagine a Ferris wheel. Imagine, where's my job? Imagine this is your cart, and like, yay, that's my cart. The Ferris wheel will take you up, and then down, and down, and then up, and up, and down, and down, and up. You see it's a repetitive, predictable pattern? Now I take that circle, I take that Ferris wheel, I'm going to unravel it and take it forever. Go up, go down, come back up. Up, down, down. You see how it's a predictable wave pattern even in a Ferris wheel? Okay? Predictable patterns you will see often, and you'll hit more of that in grade 11. But here's the idea. As I move through a circle, as the angle continues to increase, we see in a sinusoidal fashion a relationship between the height and a constant hypotenuse. That was a mouthful. So let me write this down. This. When the hypotenuse is constant, we see a relation as angle goes up, the height goes up.
What do you mean the hypotenuse is constant? Like it's going up the same thing?
Yeah, the hypotenuse isn't changing, right? the R is still the same size. So as long as we keep that the same, just like how we kept the height here the same, okay? As long as we're keeping the R the same, we notice in this circle, the height is continually increasing. So how do I write this? How do I communicate that? In a sinusoidal fashion, when the angle increases, the height seems to increase. Let me write that down. The sinusoidal relation of theta shows that it is proportional to the ratio of height to radius, or height to hypotenuse. What sinusoidal? It is a special word that describes a predictable wave pattern. Sort of like a Ferris wheel. As I go through a circle, it sort of, symbolizes a wave-like pattern. I go up, down, and then up, and then down. You see how it's basically an unraveled circle? So just a special word that I'm introducing. The reason why I'm introducing is because that's where our term comes from. You ready? Do you want to write this every single time? No. It's annoying, right? It's a waste of your time. So instead of writing a sinusoidal relation of theta, we simply write the sine of the angle that we're dealing with is proportional to
Opposite side of hypotenuse.
Yeah, we don't know what those two words are yet.
Okay.
It's proportional to the height over, in this case, what? The hypotenuse, right? Or, let's pretend we want to get just very, very technical here. Let's talk about x's and y's. What is my height represented by again, in terms of x's and y's? The y. And what is the hypotenuse represented by in this circle? The radius, right? The sine of theta is equal to y over r. That's also confusing. Mr. K, I don't want to deal with circles right now, just too much. Can you just stick with triangles? Sure. The sine of theta is proportional to the side that is furthest away divided by the hypotenuse. And instead of saying the side that is furthest away, what's another word we can replace that with? The furthest side, or opposite side. Both are the same, but by math conventions, they seem to choose the word opposite. So, the sinusoidal relation of theta is the opposite side divided by the hypotenuse of the triangle.
Wait, height side? Wait, which side is the opposite side?
Furthest from the angle in question.
Isn't that also
So if
the
this is the
hypotenuse?
angle in question, what's the furthest side?
The height.
This one.
Okay.
Right? And you'll get to see an example of that very soon. So, anyone here see the relationship between what I just wrote and that acronym?
Yeah.
SOH? Yep.
Sine opposite height.
Sine is opposite to the height. Okay? So, next. We gotta talk about, if we talked about y, what is the other what if question? What's a natural what if question that comes after this? We just talked about the y value, or the height.
How long the base is?
What if we were talking about the base? What if we were talking about the x? Well, the relationship, think about it. Just as the height and the base are probably related, I need to introduce another word. Anyone heard of the word complementary angles?
Yeah. Oh.
Not like compliment, like, you look good. Like, I'm talking complement,
Yes.
which means, yep.
Angles that have 90 degrees. Angles that add up to 90 degrees.
Angles that add up to 90. Take a look. You know how the inside of a triangle is 180?
Yeah.
90 is already taken up. So this angle plus that angle, or this angle plus this angle, or this angle plus that angle. What do they all have to add up to?
90 degrees.
90. So a complement, or the sort of partnering of sinusoidal, the complementary sinusoidal relation of theta. Do you want to write this?
No.
So what's a way to shorten complementary of sinusoidal?
Cosine.
Cosine. Or the cos of the angle is proportional to, not the height, but the base over hypotenuse. Or, it's not y, but x over r. Mr. Kim, I don't want to deal with circles. Cosine of theta is equal to adjacent over the, sorry, I should spell this out, the adjacent over the hypotenuse. Mr. Kim, what do you mean by adjacent? English language, what does adjacent mean?
It's like this. Right? Like that.
Yes.
Diagonal and
Perpendicular.
Nah.
It's like this side straight and then this side goes
Wait,
up.
like
Stand up.
perpendicular.
Stand up. Adjacent to me.
This side.
No longer adjacent to me.
That's it.
Okay? The word English, the English language, adjacent means right next to. Okay? So here's my triangle. Here's my angle. If this is the furthest side, we call it opposite. This side, by nature, we call it hypotenuse. What would you call the side that's right next to theta?
Adjacent.
Adjacent.
See,
That's
I
what
was
it
right.
is.
It's like this. Like this, like
no, it's beside him.
this. Are you slow? Look. It's like this.
Easy, easy. Okay, you fight it out. You fight it out. You fight it out. As long as fighting about math. Lastly, do you see cos adjacent hypotenuse? Do you see a connection with the acronym?
Yes.
If we're dealing with cos, it must be
Adjacent.
A to H. There's one more that we didn't compare yet. We compared y with r. We compared x with r. What did we not compare yet?
X and Y.
No.
X.
That's
Yeah, x with y. So there's one more. And I don't have time to explain that, but hopefully your grade 11 teacher will get to it, the idea of what a tangent is when it comes to a circle. Right now, what you need to know is that the relationship between the height with the base, or y with x, can be rewritten as the opposite side divided by the adjacent side. This one's tough. This one's a little bit harder to explain in a short period of time. For now, what I'm hoping by the end of this class that you'll be able to understand is the acronym stems from a simple exploration of a circle. Let's talk about how we can use that to our advantage, okay? Everyone's got a sheet in front of them?